A warm welcome to the channel. Now, whether you have landed on Mars or you are taking some touristic photos on Earth, you are generating location data. Now, it is estimated that 80% of the data in today's world has got some kind of location information. So in this video, you will see on how to use location analytics to convert this data into some very interesting and profitable use cases. I will show you on how to use location analytics to help visualize effectively this location data, proximity analysis, which helps in use cases such as facility or location planning, and route analysis, which helps in understanding and optimizing the movements between the locations. So let's get started, my friends. But before that, do not forget to subscribe the channel and smash that like button. In this example, you will see on how to visualize data related to Airbnb locations in New York. The data has got host details, the locations defined by the latitude and the longitude, the price and the customer review. Now there are about 50,000 lines in the data, and let me show you on how we can visualize these 50,000 locations on a Google map. So here is a messy way to visualize, which takes all the latitude and longitude information and puts it on a Google map. As you can see that this approach is quite messy and it is very difficult to extract any meaningful insights out of this. Now this approach would have worked if we had small number of locations, but when you have 50,000 locations, we need to go for a smarter approach. Now let me show you on how we can improve this using the power of location analytic algorithms and with some help from the City of New York. The City of New York publishes geographic data related to the New York neighborhoods on this website. This is also called as the open data. Now, geographically, New York is a city with 5 boroughs, 59 community districts and hundreds of neighborhoods. Now we can download the location information of all neighborhoods and use it for our analysis. Each neighborhood is defined in terms of a polygon of latitude and longitudes. So for example, the neighborhood Morningside Heights is defined by a polygon of latitude and longitude, what you see on the screen. Now using this polygon information, we can show the boundary of the neighborhood on a Google map. Now here you see the polygon boundary of this neighborhood Morningside Heights. Now once you use all the information downloaded from the New York City data, you can visually see the boundaries of all the neighborhoods very nicely arranged on Google Maps. Once you have defined all the neighborhood boundaries, you can use data science algorithms such as point in polygon to map a Airbnb location to a neighborhood. Now here is the result of the point in polygon algorithm shown as a location heat map. Each neighborhood is colored based on the number of Airbnb locations. So neighborhoods with a high number of locations are shown as red, and the neighborhoods with relatively less number of locations are shown as green. So as you can see that this is much more efficient way of visualization and one can extract meaningful insights out of this. Let us now move to the topic of proximity analysis, and this time we will focus on Manhattan. Now Manhattan is divided into lots, and what you see on the screen here is the polygon definition for each and every lot. Now to rent or build a facility in Manhattan is pretty expensive and can cost millions of dollars even for a very small piece of land. So here we will use proximity analysis to help us in facility planning. Now let us say we want to set up a new library in Manhattan, and the question is on which of these lots we can set up a new library. And this is where the proximity analysis will help us. So here is the result of the proximity analysis algorithm. All the lots are colored between yellow and dark purple. If the lot has got a yellow color, it means that the library is close by, and if the lot has got a dark purple color, it means that the library is far away from the lot. Now let us zoom into this map, and we see here in yellow, which corresponds to the New York Public Library. All the lots which are nearby are either colored yellow or they are colored dark orange. Now more far we move away from this lot, we see that the color of the lot becomes dark purple. So all the lots which are dark purple, they represent the lots which are underserved from a library point of view, and they are a good potential where we can set up a new library. Let us go from New York to Portugal. The example here is about taxi trajectory analysis. And the data in this example comes from GPS tracking devices installed on a taxi, which records the location of taxi every 15 seconds. Now here is a heat map of the location data coming from the taxis. As we can see that most of the taxi trajectories are in Porto, but you also have some long distance taxi trajectories from Porto to Lisbon. Now let us zoom into this map, and we can try to find out the most commonly taken routes by the taxis. Now here we see some continuous heat spots which indicate the most common routes taken by the taxi. And one of the most common routes taken by these taxis are from Matiran Maceiralos to Jardim de Palicio de Cristal to Livaria Levo. Now we can also make one very interesting observation over here. We see that there is an heat spot here, but we do not see any continuous incoming or outgoing heat spots. Now to understand this, we can zoom into this to find out what exactly is this place. We see that this hotspot is near a luxury yacht parking place. This means that the taxi are possibly waiting here to pick up or leave the passengers. So as we know that the taxi drivers are spending time just waiting, it would be a good spot to install an electric vehicle or an EV charger. So this would help spread awareness of electric vehicles and also offer some convenience to the electric taxi owners. So combining this location data and its surrounding context is a very powerful way for many use cases. Let us talk about route optimization. Routes or trajectories are connection between locations, and data science algorithms can help find optimal route between two places. Here is a result of the route optimization algorithm applied to our taxi trajectory data. This algorithm has found an optimal route between Musée de Cidade and Livaria Lelo. And this route goes through Mercado Ferreira Broges to Jardim de Cordoria and then to Livaria Lelo. We can also verify the results of our route optimization algorithm by comparing it with Google Maps. As we see in Google Maps that the optimal route between Musée de Cidade and Livaria Lelo is similar to what we have already obtained. In addition, we have some more information that this route is approximately 1 kilometer long and it takes about 3 minutes by taxi. Now we can compare the routes taken by taxis with the optimal route, which will give us an information on which taxis do not take the optimal route. So here is an example of a taxi trajectory between Musée de Cidade and Livaria Lelo, but this is not an optimal route. This route is quite long. It is almost about 5 kilometers long and it has taken about 15 minutes. So such analysis can be very useful for taxi or fleet management companies to have a better control of the fleet, which would eventually lead to a higher customer satisfaction.